used the Raspberry Pi and AI to turn my balcony bird camera photos into a live e-ink art frame, which creates art from the actual birds that land on my balcony throughout the day. So the images from here actually come from this camera over here. My outdoor camera detects the bird and takes a photo. AI then makes an artistic rendition of the image, and it automatically gets displayed on my wall. And this all happens within a minute. Now here's the thing. Getting it working was actually the easy part. A bird landed on day 2 and its art showed up on my screen. But making it look this good on a display that only has 6 colors took quite a bit longer. Along the way, I ended up rewriting a 40-year-old Macintosh algorithm. And at one point, I made my code 15 times faster by deleting the fast math library. Yeah, seriously. In this video, I'll talk about the idea, the parts I used, how I wrote the software and built the frame, perhaps you'd like to make one too, and some of the issues I faced. Oh no. And tricks I learned to fix them, so you won't run into the same problems. I'm okay. So, how did this start? My friend sent me an Instagram video where this guy used the Merlin app and generated AI bird pictures based off of the predicted bird species from what the microphone hears. And I realized I already have a bird camera on my balcony that I built with Home Assistant and Frigate, and a custom ML detector I trained to identify bird species, but that's a side project. Could I show those pictures on an e-ink display? I built dumb AI things before, so I figure I should be able to get something together quickly. So I sketched a goal, a normal looking art frame, 1 wire at most, super subtle, you know. And when a bird lands outside, it magically appears on my wall in this beautiful artistic rendition. Piece of cake. I've never used an e-ink display before, so I'm not sure what to get. I really want a big colorful display that refreshes instantly, but physics disagrees. With the color display, it takes 30 seconds of flashing to refresh, and that could be obnoxious. Conversely, the monochrome displays can refresh in under a second. Really, the lack of color is sort of a deal breaker. Let's go with the Waveshare 7.3-inch color display, mostly because it's cheaper and next day shipping. I can always upgrade later. I'm not sponsored, but I wish they'd send me money. Birds don't come that often. If the image refreshes at most every 10 minutes, I think the flickering will be fine. I already own a Raspberry Pi Zero from previous projects, like my home security bird camera. The display won't arrive for 2 days, but that's fine because I can start writing the code now. So my outdoor bird camera is already sending images to my home server. I use the open source software called Frigate for this, and it has a nice API for programmatically getting these events. I trained it to identify bird species. It's pretty cool. Can I get the latest bird event by camera name? Good, that seems to work. Now for the image. There's latest.jpg. Wait, no, that's the entire image. I want the cropped image of only the bird. Let's try thumbnail.jpg. There we go, that's better. So the idea is to have a little script on the Raspberry Pi that checks Frigate for new bird events. Whenever a bird flies by, it'll download that image and draw it on the e-ink display. We'll only update every 10 minutes, so bird images stay up for a while. Let's make it a service on Linux so it will automatically restart on power loss. Since there's no display yet, let's vibe code a little web dashboard.
Claude, sweetie, you need to switch to Claude.
I'll store the server config using a tiny local SQLite database hooked up to an admin page on the web dashboard so I can modify everything without needing to SSH in. And it'll survive reboots. I'll start the server locally on my desktop, and there it is! Sweet. The event and thumbnails are showing up. As the day goes by, I can see new events coming in. There's a web dashboard too. Woohoo! The e-ink display has arrived. So cool. Wow. I'm not entirely sure about which side the ribbon cable goes in. I'm pretty sure it goes in this way. It's fine, it was the other way. I'm slightly disappointed closing the latch didn't make a click sound. Alright, I'll flash the SD card for the Pi Zero with the official Raspberry Pi imager, choosing the headless install to save some compute. Then I just plugged the e-ink hat on top. This took some pressure to close. Then let's test the display using the official Waveshare GitHub demo code. And hey, hello world. It's flashing! This is awesome! This is the first time I've ever seen a color e-ink display like this up close. I can see the little physical ball pixels of it. What a cool effect. I still need to peel the protective film off, but I'll try to save that for once it's in a frame. Now all I need to do is to push the web server code onto the Raspberry Pi, And there it is, showing up on the network as Bird Pi. Alright, let's push our own image. One thing to note about e-ink displays, the pixels are literally tiny physical colored balls, and each one can only show one of 6 colors: black, white, red, green, blue, or yellow. Any other has to be faked by dithering, using a combination of the surrounding pixels to blend to that color. This is basically what color printers do right now. Waveshare has factory driver code that does this automatically, so let's try that. Here's the camera photo dithered with the factory driver code. Let's send it to the panel. Hey, look at that. That's pretty cool. It's also kind of muddy and bland, honestly. I wonder if we could do better. What if we do things like boost the contrast and color saturation before sending the image? It is a bit better, but honestly the original photo is kind of blah to begin with. However, the goal was never a great photo. The goal is bird art. Maybe I can use AI like Google Nano Banana to restyle the photos into something designed for this display. Something with bold, flat colors, high contrast, something that emulates the interesting artistic styles like Cubism or cartoon or Charles Harpley. I've worked with Google's APIs before. It's straightforward to experiment on the AI Studio website. So I give it the bird photo and ask for a stylized, minimalist, high contrast, vector style graphic. Holy crap, that's amazing. Alright, I didn't expect this to work as well as it did. A nice tip with this site is that you can click here to export the session settings directly into Python code. And I can estimate token costs before automating the process. I feel like I should be getting paid to say this. I'm not. This worked way better than I expected. Let's write this API call into our Pi now, so when a frigate bird image comes in, it'll send that API call with the prompt, and the response should be this artistic version of it. Let's push and... yes! That looks incredible. And the economics works out too, I think. It's supposedly less than a cent per image. In practice, I've seen it being actually a couple cents per image. With the amount of birds I'm seeing daily, that's maybe $1 or $2 every few days. I can live with that. That's less than coffee. As a bonus, Nano Banana can use Google Image Search to recognize the bird species automatically. So I ask it to add the species name right into the art as stylized text. Just for comparison, I add the original camera thumbnail in the bottom left corner, the actual bird image that inspired this piece. It's fun seeing where the AI took creative liberties. So even with the AI art, the factory dithering muddies things up. Most dithering, including the Floyd Steinberg in the factory driver, passes on all of the error, which is technically more accurate, but it kind of smears everything. The algorithms behind dithering are actually pretty simple. You go through the image pixel by pixel, and for each one, you pick whichever of the 6 ink colors is closest. That pick is usually a little bit wrong, of course. So instead of throwing the error away, you push it onto the neighboring pixels you haven't visited yet, and they overcompensate in the other direction. This causes the errors to average away, and the human eye blends it all together into something that looks like that color. Although it turns out closest is doing a lot of the heavy lifting there. I'd prefer a visually cleaner, more vibrant style, so let's write our own dither algorithm. The specific algorithm we use is one invented by Bill Atkinson for the original Macintosh. Atkinson only passes on 3/4 of the error. It has a bit of leeway, which, while less accurate, it makes the highlights stay clean and the image stay punchy, which is exactly what we want. We'll use a formula called red mean, which weights red, green, and blue by how sensitive the human eyes actually are to each one. I also boost the saturation and brightness a bit before dithering, because e-ink is less vibrant than a backlit screen. This brightness boost did cause me some issues later though. Another thing to remember if you're doing something like this, always dither at the very last step, after any resizing. If you resize a dithered image even slightly, most default resize algorithms will anti-alias and you'll get blended colors again. I wasn't paying attention, and I noticed I was getting little noise pixels in the display that bugged me for hours. I was thinking the display was breaking. Another tip, a Pi 0 can be slow in weird ways. My first Python version of this algorithm took 9 minutes per image, and the slow part generally was surprising. I was using NumPy, the fast math library, once per pixel, a place where you'd normally want to be using a fast math library. But in this case, NumPy's per call overhead was choking the poor Raspberry Pi. If we replace this with a slightly more complex inner loop with simple floats instead, still the same algorithm, and now it takes about 50 seconds. Removing the fast math library actually made it 15 times faster. This was still a bit too slow, so I moved that same loop to C instead. Basically manual numpy, but done correctly. And now it dithers in about 1 second. That's a lot more like it. Those light blue skies kept coming out as pure white on my display. It was the brightness boost I added earlier. It was clipping light blues all the way to white before the dithering even saw it. As I was fixing this, I went down a rabbit hole and ended up with a whole third rendering mode that's my new favorite now. Instead of dithering everything, it first splits the art into flat color regions, and then each region either becomes a single solid ink, or it gets filled with an ordered pattern like chevrons, stripes, or cross-hatching. So a sky comes out as this pretty blue on white pattern texture, and only the small textured parts still get dithered. And on the panel, oh yes, definitely better. The color is consistent, nothing smearing. I love how this looks. I think the results look almost hand-printed, like a woodblock print or something. And honestly, it's a big part of why these images look as good as they do. It renders in about 12 seconds on the Pi, which is fine since we're running this every 10 minutes or so anyway. I think it's time to order a frame. It's here! I went with an 11 by 14 frame. That's an inch deep, so all the electronics can hide inside. By the way, I did try an 8 by 10 frame too, but the 11 by 14 proportions just felt more classy. The e-ink display's active area is not exactly 4 by 6 inches, so I'll have to cut my own mat board to fit it precisely. The hole gets cut to the display's active area, not the whole panel. This way we don't see the circuits on the edge.
There it is. Okay, that's pretty good. Yes.
I prop up the frame on
Gotcha.
yoga blocks
Oh, oh shit. Okay, it's okay. Everything's okay. Whew. Whew.
so I can look at the display as I line it up on the mat board.
Okay.
Then some gaffer tape to hold it in place. I'm glad to have it mounted because this panel is pretty fragile.
Look at that.
And I've been afraid of breaking it this whole time. Which means it's finally time to peel the film. Okay, full disclosure, I peeled it the day the display arrived. It was too tempting. The Pi with the e-ink hat is about 8/10 of an inch tall. So I cut a hole in the backing board, and the electronics can sit inside the frame but outside the mat.
There we go. So as long as you have 20 millimeters of clearance, you're going to be good to go. Like if you really wanted to, you could do this. This would be less, but I think it's fine. Let's see if we can see this.
Okay, all that's left is the power cable needs to get out of the frame somehow. I have a small USB-C extender with mount holes, so I'll drill a hole through the frame, and then the cable can run through the hole.
Sweet.
And when mounted from the front, you can't see a thing.
Of course, it's not in focus.
One wire, just like our original sketch. Finally, it's time to mount it on the wall. Ah, this looks amazing. I also added a small feature. Every piece shows the name of the art style it's painted in, right on the frame. I think it's important to show the original artist's style with each piece. It's thanks to their creativity that we get to see these lovely homages. A note on power. Since it's e-ink, you could use a battery and get rid of the power cable entirely. The panel holds this image even without power, and the Pi Zero could deep sleep and only wake up every 10 minutes. For me, I'm fine with one wire. That way it can stay up year-round without me having to recharge another battery. I also added a little weather and clock strip along the bottom, so now the frame refreshes every hour with fresh weather. It's nice seeing the weather at a glance, and it gives me an excuse to admire the art. And for anyone considering building something like this, it's absolutely a blast. I'm a huge fan of e-ink now, and the color panel really is something special. There are some real trade-offs. Color e-ink displays are expensive or small. The colors are more muted than the equivalent colors in art. The 30-second flash when the image changes could be distracting if it's in view of where you watch TV, for example. So far it's not that distracting, but if it would annoy you, look at the fast refresh monochrome panels. I think I might try to build a calendar or home assistant display with that. If you enjoyed this, comment and like, and please subscribe if you'd like to see more projects like this. There's something really special about walking past and seeing at a glance the last actual bird that visited my balcony as art. It feels more personal, like the birds are saying hi. I'll admit, I might be seeing things, but hey, I think you get it. I loved making this project. Thanks for watching, and I'll see you all next time. Cheers.